Hello, in this video we will be covering section 6.2, which is about AAS triangle congruence. AAS triangle congruence. First, it stands for angle, angle, side. And what AAS triangle congruence tells us is if we have two angles in a triangle and a non-included side, so a side that is not in between the two angles, if those are congruent to two angles and the same unincluded side on the other triangle, then these two triangles are automatically congruent. So let's look at example number 1. We want to determine if these two triangles are congruent. So if I go through, in the first triangle I have an angle, another angle, and an unincluded side. So the side is not in between the two angles. And I need to make sure that the other triangle has the same two angles and unincluded side. Well, we have two angles and the unincluded side. So yes, these two triangles are congruent. And our reason would be the AAS theorem. Example number 2. Again, we're going to check for angle, angle, side. Well, you'll see in the first triangle that we have angle, side, angle. The side is in between the two angles, so we would call that angle, side, angle. But in the second triangle, we have angle, angle, side, where the side is not in between the two triangles. So because these two side lengths are not in the same spot, these two triangles are not congruent. Lastly, let's look at example number 3. Given that JM bisects KN and angle J is congruent to angle M, we want to prove that these two triangles are congruent. So before we begin, let's just label some information on our picture using the information we are given. First, we are given that JM bisects KN. If we think about what the word bisects mean it cuts it perfectly in half. So if JM is bisecting KN, I know that this side of KN has to be congruent to that side of KN. The next piece of information that we are given is that angle J is congruent to angle M. I'm just going to label that in my picture. Angle J is congruent to angle M. We need at least one more piece of information to prove that these two triangles are congruent. So I have to use the picture to find something else that I can prove is congruent. Well, we know that angles across from each other, such as this angle and this angle, are called vertical angles. And vertical angles are always congruent with one another. And now when I look at these two triangles, we have an angle, angle, side being congruent with an angle, angle, side. So we know that these two triangles do need to be congruent. But now let's use this information to write the proof. First, let's write our given statement in the top line. So JM bisects KN. That was given. And remember when we were labeling our picture, right after we read that JM bisects KN, we realized that that means that KN must be congruent to LN. Excuse me, I'm going to fix this real quick. It should actually be KL. KL is congruent to LN. right? Remember, this side was going to be the same as this side. And that was because of the definition of bisect. The next thing that we did was read the second part of our given statement, which said that angle J was congruent to angle M. And then the last thing we did was we knew we needed a third piece of information. So we looked at our diagram and saw these two vertical angles. And we labeled them congruent because vertical angles are always congruent. So I'm going to write angle JLK is congruent to angle NLM. And I'm going to write vertical angles theorem. And then lastly, we had angle, angle, side, matching an angle, angle, side, so we know the two triangles are congruent, which is exactly what we're trying to prove. So we're going to put that in the bottom row. So triangle JLK is congruent to triangle MLN because of the angle, angle, side theorem.